Good. How are you?
How's your track going?
Good.
Good. All right, we're doing 8 through 14.
Yes.
Okay. Jenna, do you know how to do 7?
Yeah, I was able to do 7.
Okay. 7 actually has a little trick to it that one can do. You don't have to do 7 the hard way. In other words, 1 minus x is the negative of x minus 1. So watch what happens. Hold on a second. Sorry. There's probably an easier way to do 7 than the way you did it. I just want to point it out. Notice that I can write this way. Realize you can do that with that 1 minus x. You can put x minus 1 and change the negative, change the plus to a negative. And now the common denominator is the same, so the answer is x minus 1 over x minus 1. 1 is the answer for 7.
Okay.
Let's look at 8. 8 looks kind of interesting. Wonder. Well, let's do it the normal way. What's the common denominator going to be on 8?
So
at this point, notice that these are not the same thing.
right.
That is not the same as the denominator on the right. So my common denominator is just the product of both denominators. Let's see what happens here. There may be a trick that I'm not seeing, but we'll find out. What goes here?
1.
When I say what goes here, you got to make sure you put something there that equals that fraction. What is it going to be?
Oh, so it's x minus 1 squared, right?
Yeah, and the reason I don't multiply the two bottom ones is for that exact reason, is that when I figure out how to put that there, now I can easily check and make sure that I haven't changed that fraction. And that's the goal, is you're not trying to change the fraction. You're just trying to turn it into one that has a different common denominator. And on the right side, what is the right numerator?
It's x squared minus 1.
Correct. And you do want to put that in parentheses. Now, we're going to operate on the numerator. So we need to expand the top left one. What does that expand to?
So that's...
Got to FOIL it. X minus 1 times x minus 1.
Right.
So it's x squared minus 2x plus 1. That's what that is. Okay?
Okay.
Now, I'm going to remove the parentheses over here. So what do I have on the right?
X squared minus 1.
Nope. This negative sign has to be applied to everything in the parentheses.
Oh, x squared plus.
The x squared, and I got to put it on the minus 1, which turns it into a plus 1. Now, that cancels with that. And it looks like I have minus 2x plus 2 in top. And in bottom, I got x minus 1 squared times x squared minus 1. And I simplify that. What can you factor out of the numerator?
A 2.
A minus 2. The reason you want it to be a minus 2 is you want this to be that. Now,
All right.
I've still got that in the denominator along with this. So now what can I do? X minus 1 in the numerator, and I got an x minus 1 squared in the denominator. If you had x over x squared, what would that turn into?
1 over x.
Okay, so do the same thing here. In other words, you cancel that whole thing out with that exponent. I'm reducing that exponent by 1. So
Yeah.
my final answer is minus 2 over x minus 1 times x squared minus 1. And you can put, that's the answer they're looking for. They don't want you to multiply those two together.
Right, yeah.
It's possible they might want you to factor it. That's difference of perfect square, so I could turn that into x minus 1 times x plus 1, and then I could go back and put that as squared again. But I don't know that you need to go to all that trouble. That's a perfectly reasonable answer. Now,
Right.
I noticed that every problem on here is the same in the sense that this is a squared minus 4, and that is a plus 2 squared. And this has difference of squares. I'm wondering if that might not be an easier way to do these. In other words, let's look at number 10 since we can both read it. And then we'll go back and we'll do 9. Let's see maybe if there isn't an easier way to do this. If I factor this term on the right, is that going to make it easier or harder? That is minus 3 times x plus 3. You know what? This makes it easier. This is what we want to do on 10. Because what's the common denominator now?
X minus 3 times x plus 3.
Exactly. So, in other words, I have a smaller common denominator than I would have gotten had I just multiplied those two terms together. Hold on. Bear with me. I'm writing all this stuff out. That's why it's certainly easier than having to write the problem also. Top left, what is that going to be?
7 times x plus 3.
Which is 7x plus 21. We'll go ahead and distribute that. We know we're going to have to. Top right is what?
Still 4.
Okay. So I'm going to add the 21 and the 4 to get 25. And there's what we've got. Now I can't factor anything in the numerator, so that's my final answer. And it was definitely different than doing it this way. So we're going to experiment with doing the rest of them like this. Actually, probably could have done that number 8 that way. Or could I? No, let me just take a quick peek. If I do number 8, the way I'm suggesting doing it, I would write it like that. Oh, no, I would write this as x plus 1 times x minus 1. And yeah, it does produce, no, I got to have a, I'm going to need an x plus 1 over here, so it doesn't save a step. And I'm going to need an x plus 1 right there. So that's my common denominator right here. So factoring it first didn't really save anything. I still had to end up, no, it did save 1. I got x cubed here, and I was going to have x to the 4th as a common denominator there. So I didn't do 8 correctly. I should have done it this way that I've done. You see the difference?
Yeah.
In other words, you never want a common denominator to be bigger than it needs to be. For example, if I have 1 over x minus 1, and I'm adding it to 1 over x minus 1 cubed, what's my common denominator?
X minus 1.
It's got to be, the common denominator has to be divisible by that term and that term. That's the definition.
So x minus 1 cubed then.
Exactly. That would be a common denominator, but I wouldn't have to multiply that by that to get x minus 1 to the 4th. In other words, x minus 1 to the 4th is a common denominator, but it's not the least common denominator. And
Right.
That's the only mistake I made when I did 8, is I had a common denominator which allowed us to solve it, but it was not the least common denominator. All right, let's do 9 here. And this time I'm going to do 9 by factoring that difference of perfect squares. Let's see if it helps. A plus 2 times a minus 2. And I'm subtracting this. And I'm going to factor that into a plus 2 times a plus 2. So it is going to help. Tell me what my common denominator is going to be.
A plus 2 squared times a minus 2.
For the moment, let's write it like this. And you'll see why in a second. Because we got to get the numerator. And figuring out the numerator is much easier if you leave the bottom factored instead of multiplied together. So what's the top left numerator?
4a minus 8.
I think it's plus. Isn't it 4 times a plus 2? Here, let me back up a step.
Yeah. Yeah.
In other words, by skipping that step, we left ourselves open to making an easy error. Whereas if I put it in there like that, now I can see that that is identical to that. Because I can see the a plus 2 cancels with that a plus 2, and now I've got what I started with.
Right.
So I wouldn't skip this step. I would always put this in there, merely because it gives you a great chance to check your answer. What about the right side?
So it's times, so 3a minus 6.
Yeah, well, let's do it like this again, and I'll explain in a moment. Because that's a subtraction sign, everything in the numerator on the right has to be subtracted. So I can write 3a minus 6, but I got to put it in parentheses. Okay?
Right.
So let's just continue. Now I'm going to distribute the top. 4a plus 8 on the left. And I'm going to distribute and get rid of the parentheses at the same time. So that's minus 3a. That would have been minus 6. Now becomes a plus 6. And I have the same common denominator. So now if I combine this, I get a plus 14 all over that common denominator, and I'm not going to be able to do anything else. In other words, if that was an a plus 2 instead of an a plus 14, I'd be able to simplify it more. But when you're dealing with a variable with a number added to it, it's got to be exactly the same. So that's going to be your answer, final answer.
All right.
But yeah, by factoring each of these first, notice that if I were to do this problem by just multiplying that by that to come up with a common denominator, I'm going to have a to the 4th. Whereas by factoring it first, I ended up with an a to the 3rd. So I'm 1 degree smaller, and that makes the rest of the problem easier to do.
All right.
So it definitely helps factoring first. We did 10, let's do 11. Common denominator, I'll let you do it this time.
So it's x plus 5 times x minus 5 times x minus 5.
Almost. Factor the x squared minus 25 again.
Oh, it's x plus 5 times x minus 5.
Okay. So even though that's an x plus 5 squared, let's not square it yet. We don't want to.
Okay.
Okay. Now we're adding.
Yeah.
Whoops. I did it right the first time. And the common denominator is the same over here. Goes in the left top numerator. Let me give you a little bit better method of figuring out how to get that top left numerator. Okay? Take that, divide it into your common denominator, take the answer, multiply it by your numerator. So I'm going to multiply it by the numerator. What else has to be in there?
X squared or x.
Don't square anything yet. Leave everything in factored form. You'll see why.
So x and then 5x.
Okay, what is going to make this look like that? we're trying to make it look like x over x plus 5. So these two things need to both be in the numerator also. So the way I do it is like this. Just like that. And now I can see that those cancel, leaving me x over x plus 5, which is what I started with.
Okay.
Okay? But here's what I did. I want you to understand there's a more methodical way to do it. I took my common denominator, this thing right here, and I divided it by x plus 5. Well, what do you get when you do that? You get that. Now I multiply that by whatever was in the numerator, in this case x. So that's how I got that. And that's how you do it always. I'm going to do the same thing over here. I'm going to divide the x plus 5 times the x minus 5 into this common denominator. What do I get? And whatever I get, I'm going to multiply it by 10x.
Okay.
What's it going to be?
So x squared.
No squaring.
Oh. So
Like no
just
swearing. No swearing, only no squaring.
so x plus 5.
That's it. Now look at it carefully. Is it any different than 10x over x squared minus 25?
No.
That's what you want. Now you've done it correctly. Now we don't want to be canceling anything out here because we did this for a purpose, and it's so that we can operate on the numerator. Well, what's the new numerator become? Over here we've got x times x squared minus 25, which becomes x cubed minus 25x. So that's what that is. And then I'm adding to it 10x squared plus 50x. Combining them all, I'm going to write it right here so I don't have to rewrite that long common denominator. I've got x cubed plus 25x, excuse me, plus 10x squared plus 25x. That's what that turns into.
Okay.
Now, I'm still not done. Because notice what I can do here. I can factor out an x. In other words, there's my answer, right?
Yeah.
But not really. Here, I'm going to factor out an x from the top, leaving x squared plus 10x plus 25, which factors into x plus 5 times x plus 5. That is my new numerator.
And those could factor out. They cancel out the other two.
In other words, it cancels those two out with those two, and I end up with just x minus 5. So my answer is a very simple x over x minus 5. Now, just let me look at that a second. That seems like an awfully strange answer, but wasn't really. It's a little harder than the others because we ended up with this numerator here that could be double factored. In other words, I can factor that all the way down to 3 factors, and 2 of them happen to be the same as in the denominator.
Okay.
Trying to think for a moment. You know what? I didn't have to do it this way. Watch, I made a mistake here also. If I've got x over x plus 5, and I'm adding that to 10x over x plus 5 times x minus 5, what's my common denominator?
X plus 5 times x minus 5.
Exactly. And somehow I ended up with a common denominator that was cubes. In other words, we threw in an extra x plus 5 that we didn't need. Common denominator should have been just x plus 5 times x minus 5. And then it makes the problem a little easier and takes away the need to do that little trick I did at the end with the numerator. That was only because I didn't use the lowest common denominator. If I use this common denominator, then I got an x times x minus 5 there, and I've got a 10x there. Now we're going to get the same answer. Don't misunderstand me. It's just that we'll be dealing with smaller. Notice that I don't have a cubic anymore in the numerator.
Yeah.
Whereas when I did it the first time, I had a cubic because we had one too many terms in our common denominator. So the trick on every one of these problems is to get the most efficient common denominator you can get. So let's look at 12. You know 12 is going to be a factoring of that bottom. What does it factor to?
So
And a hint as to what one of the factors probably is?
x plus 7.
Probably.
So
if I'm guessing that x plus 7, that means this has to be x minus 4. Does that give you that middle term of plus 3x? It does indeed. Now, I know what's my common. I've got an x plus 7 over there. What's the common denominator between these two?
x plus 7 times x plus 4, or minus 4.
Right. And so this will work out fairly easily. Already got the left side solved. What's the right side going to become?
X times x minus 4.
Good. Now the numerator becomes 11x plus x squared minus 4x, which is what? X squared plus 7x all over. We are going to be able to reduce it a little bit. There's our common denominator. What can I do with the numerator?
So you can factor out an x. So it's x times x plus 7.
And then the x plus 7's cancel, leaving me with just
x over x minus 4.
So it's x over x minus 4.
Yep.
Okay. I suppose there's no rule that actually says you have to use the least common denominator. If I was a math teacher and somebody did these without using the least, and just used a common, I'd be hard pressed to mark them wrong. There's nothing wrong, it's just not the most efficient way to do it. So on 13, same kind of problem. We know we're going to have to factor the right.
Right.
And we know one of those factors is probably x plus 5. What's the other factor? Got to get a plus 20. What's it got to be?
X plus 4.
And then check, make sure that gives you 9x as a middle term. It does. That 5x, that's 4x, that's 9x. Top left is what?
5 times x plus 4.
Top right is what?
Just the 2x plus 5 still. Or, yeah.
Yeah, I missed my common denominator on this side. Let me put it in there. Okay, simplify the top.
So it's
Just start from the left and move right.
so 2x.
Hold it.
Oh wait.
Start from the left.
Okay. So 5x plus 4.
No.
Crap. 5x plus 20. Sorry.
Sorry. This is the part that I'm wondering if you're going to get right. It's the rest of it.
Minus 2x minus 5.
Correct. Even though I didn't put the parentheses around there, I should have, just so you'll never forget to not apply that negative sign to the 5 also. Okay, so that becomes 3x plus 15, which becomes 3 times x plus 5. And our common denominator was x plus 4 times x plus 5. So there's our answer. And 14. Is that the last one?
Yeah.
Factor the top and the bottom. Whoops, I can't see the rest of this problem, can I? You're going to have to read me the rest of it if you're looking at it. Or can I scroll? I maybe can scroll. Yeah, I'm sorry. I didn't realize I just didn't have it on page fully. Now my ink thing doesn't want to work. There we go. Okay, when you have a problem like this, just factor everywhere you can factor. And you factor the top left.
So that's
No, not without introducing radicals. It is x minus square root of 11 times x plus square root of 11, but those square roots of 11 aren't going to do us much good. So
right.
I'm not going to factor the top yet. I'm just going to write it. What the heck's happening here? How come this thing is not working? Hold on. Let me do this again here. Technology is great, but it's not perfect.
Yeah.
And when it screws up, it's really a pain. All right. So the top is going to stay at x squared minus 11 for the moment. Factor the bottom left.
So x minus 4. Oh wait, no, plus 4.
Nope. Both signs are negative.
And then x, oh, and then x minus 3.
Okay. What's my common denominator going to be?
X minus 4, x minus 3.
What's the top right going to be?
Um,
Remember, it has to look like this, only with this common denominator. So always write what's there, put parentheses around it, and now what else has to be there so that it looks like this right-hand fraction over there?
x minus 3.
Yeah, that's the way I do it. The technical way to do it is to divide that into it and multiply it by the top. But I find this much easier. In other words,
Yeah.
I can look at this in 1 second and tell you, is that the same fraction as that? Yes, my x minus 3's cancel. I'm left with x plus 1 over x minus 4. So I suppose if it got really complicated, it might be a little harder to do it that way, but these you can certainly do that way. Now, again, that negative sign is going to potentially create problems. So what's the next step?
So you can,
You have two fractions and they have a common denominator. What can you do with those two fractions?
combine it.
Do it.
So x squared minus 11.
Minus 11. And then minus, and then put big brackets, because what do you have to do next?
Multiply x plus 1 and x minus 3.
And make sure that it's all in parentheses, because that whole thing is going to be subtracted. If you don't use brackets, you can really easily make a mistake on the sign of the number. So when you multiply those two together, you get, I'll do it quickly, x squared minus 2x minus 3. Now remove the brackets and tell me what I'm going to erase all of this over here, and I'm going to write the new numerator right there.
So it's x squared minus 11 minus x squared plus 2x plus 3.
Okay, that cancels with that. We've got a total of 2x minus 8. What else can I do?
Factor out a 2 on the top.
Yep.
So it's x minus 4, and then get rid of the x minus 4.
Correct. And you end up with the same answers we've been getting on every one of them. A number over a linear term.
Yep.
All right. I think you know how to do it.
Yeah, I'm getting the hang of it.
You good to go, or you got other stuff you want to work on?
That's it.
Okay. I will talk to you Thursday at 7.
Yep. We're
getting into the part of the year where if you're going to cancel, I would appreciate some advance notice, just because if you cancel early enough, I can fill that time slot.
Right. Yeah.
I'll go ahead and leave you with Tuesday and Thursday 7 o'clock time slots through the end of the year. And I don't mind if you need to cancel one, that's fine. Just give me as much notice as you can.
Yeah, that's fine. I'll do that.
Otherwise, I will talk to you Thursday at 7.
Yep. I'll talk to you then.